Hello everyone, this is Dr. Rajesh. Today I am with you with my new topic on gradient, divergence and curl. In this lecture we will study the definition of gradient, divergence and curl and also see their physical meaning. Firstly we see gradient of a scalar function phi is denoted by del. This is known as del and read it as gradient is denoted by del phi and is defined as del phi is equal to this is an operator and it is called this is called del operator. This is called del operator. Phi is the scalar function and this whole quantity is a vector quantity. I, j, k are the unit vector in the direction of x, y and z axis. Fine. So this is a vector quantity. Phi was a scalar. So del phi is a vector quantity. Del phi is a vector quantity. Phi was scalar. Therefore, gradient is also denoted as grad phi. Del phi of a scalar function is a vector quantity. So this is the definition of gradient. Next we see what is the definition of divergence. This is the definition. Divergence of a vector function. It is important to note here that divergence of a vector function is taken while gradient is of a scalar function. So divergence of vector function, this is denoting the vector quantity. Arrow is denoting the vector quantity. Is denoted by del dot A and is defined as this one. Say del is an operator. It has component likewise I, j, k, curly by curly x, curly by curly y, curly by curly z. This is an operator called del operator and these are the components of a vector function a1, a2, a3. So using the definition of dot product, this will differentiate a1. So curly a1 by curly x, curly a2 by curly y, curly by curly z of a3. This is a scalar quantity, this is a scalar quantity, this is a scalar quantity. Sum of scalar is a scalar quantity. So there is no exaggeration in saying that this is a scalar quantity. Therefore, divergence of vector is a scalar. Means vector when applied divergence goes to scalar. So this point is important to keep in mind that divergence of a vector quantity is a scalar quantity. Next we see the definition of a curl. It is given as curl of a vector function A is denoted by del cross A and is defined as del cross A. This is del operator. We have used the definition of del operator and cross is as such A is a vector quantity. So firstly we will give the definition in the compact form. This can be further written as is equal to I. This cross will go inside. Here is operator, it requires vector quantity, so cross will not be applicable upon it. It will cross this one and it will come over here. Here will be cross. Now this A will enter, this will come over here and we are going to write curly by curly x of A. Similarly J cross curly by curly y of A plus k cap cross curly A by curly z. So this is the definition of curl in symbolic form. Otherwise the curl can also be calculated as like we write I, j, k component of del curly by curly x, curly by curly y, curly by curly z and component of a1, a2, a3. Now we see, we will take these two, okay, and it will be I cap, and this will be like this and this. So this will be positive quantity, and when going up this will be negative quantity. So this will be curly a3 by curly y minus curly a2 by curly z, and here will be plus j. Now first and third, in the for the middle we know it is in the reverse order. It will be curly a1 by curly z minus curly a3 by curly x plus k cap. It will be curly a2 by curly x minus curly a1 by curly y. So here we see that these are the definitions. This is given by equation number 1 and equation 2. So both are the definition and both are correct definition. We could be using any of the definition that is as per the requirement of the question. So here we see from here a was a vector quantity, and this whole has come I j k is a vector quantity. So here result come that if a is a vector quantity, then vector applied with curl gives vector. So here we see that vector function, when the curl is taken, then it gives the vector quantity as such. So vector remains the vector under the curl. So we have so far studied the definition of gradient, divergence and curl. Now we will see what are their physical meaning. So here we see physical meaning of gradient. Gradient we all know is given by this definition we have studied. Like the derivative, normal derivative is always along the tangent direction. Similarly, this del phi is a spatial derivative, so this is along the normal direction. So this is can be shown with that particular figure. Here you see this is the three-dimensional curve, okay, and this is the normal to the curve. So grade phi is always like normal derivative, it is normal to the curve. So grade phi is normal to the curve. Therefore grade phi del phi can be written as having the direction, magnitude is this one and direction is along the normal, where n cap is unit vector normal to curve. So grade phi is giving the change in phi along the normal direction to the curve. And if we are asked to find the component of gradient of phi in the direction, like this is the direction A, and if we are required to find out the component in this particular black arrow direction, this is A, then we know that component of del phi in the direction of A vector is equal to del phi dot A cap, that we have studied in earlier lecture where we discussed the component in particular direction. So there we have taken this formula, from there we have taken this formula. So this is further equal to del phi n cap dot A cap. So we know that this is further equal to del phi n cap mod A cap mod and cos theta, where theta is this particular angle theta. So this theta can be maximum when this cos theta is 1, and cos theta is 1 when theta is 0. So this is maximum when cos theta is 1. Therefore grade phi has maximum value in the normal direction. Theta 0 means n cap will be parallel to a cap, so that will be normal direction. So grade phi, change in phi is maximum along the normal direction. So grade in the direction of normal, the change in phi is maximum, which is the direction of grade phi. So grade phi gives nothing but change in phi along the normal direction to the given curve. So this is the physical meaning of gradient. Now we see the physical meaning of divergence. Physical meaning of divergence. Divergence of a vector field gives the net flux flowing through the given surface held normally to the path of the vector field. It is further illustrated with the help of the following figures. In this particular figure, we are showing what is zero divergence, what is negative divergence, and what is a positive divergence. If let us say this is a point, the net flux is flowing out of this particular point. So this is flux is out flux. It is out flux. So del dot A vector is greater than 0. So flux is positive. Flux is positive. And if we say that net divergence is negative, when there is net divergence entering at particular point, then we say that it is inward flux. Inward flux. And del dot A is negative. Del dot A is negative. Next, here the number of lines entering are equal to number of lines leaving. So there is no net flux in this at this particular point. So we can say that here del dot A is equal to 0. So if flux of a vector field is 0, then that field is known as solenoidal vector field. This is very important. In some question it is asked that prove that the given field is solenoidal field. So we have to prove that its divergence is 0. So this is all we have the physical meaning of divergence. Now next we will see what is the physical meaning of curl of a vector field. Here we will see the physical significance of curl of a vector function. It is given by del cross A, or it can be written as curl A. Likewise, divergence is written as div A del dot A. Now here we see this, we have to see what is the physical meaning of curl of a vector function. So this is illustrated with the help of these two figures. This is one figure and could be named as figure 1, and this is figure 2. So say this is vector field is A. So curl of vector field gives the rotation tendency of that particular field. Like here we see this, from this figure it is clear that this has some rotational tendency in this particular direction, and that direction is anti-clockwise direction. In this direction it has got the rotational tendency. So we say that it has some rotational tendency. So the field is rotational, and if the field is rotational, then we say that curl A del cross A is having some value is not equal to 0. While we look at this has no rotational tendency. Arbitrary fields vector are arranged, so the net field has no rotational tendency. So in this case we can say that del cross A is equal to 0, and that kind of field whose rotational curl is 0, then that is called irrotational vector. Whose curl is 0, whose rotation is 0, is called irrotational vector. So this is the physical significance of curl, that it gives the rotational tendency of that particular vector field. If curl is non-zero, then field is rotational, and if curl is zero, like in figure 2, the field is irrotational. So this is all I have from this lecture. In this we have discussed three important topics: gradient, divergence, and curl. Not only we discussed their definition, but we have also studied their physical significances through very illustrative examples. So if you have liked the video, please like, subscribe, share, and comment. And this is Dr. Rajesh saying you goodbye. Thank you for watching.